My name is Dietrich and I'm a field application engineer at BROADCOM. BROADCOM is a technology leader in the areas of wireless communication, data center communication, set-top boxes, and also industrial and automotive applications. BROADCOM as a company has grown very strongly in the past 20 years and have a very strong IP portfolio, very strong financially stable company, and we're able to invest in a lot of new products and technologies and offer the latest technology for our customers. Being strong financially means that we are also a good long-term reliable partner for customers. Basically, an optocoupler is an isolation device. The function of an optocoupler is to safely isolate voltages from a high voltage level to a low voltage level. Another way of looking at it also is isolation in terms of a noisy environment. So not only the safety factor, but also common mode rejection or noise that is happening in a factory, for example. There are other isolation technologies available on the market. There is magnetic or capacitive technology, and the basic difference is the way the signals are actually transferred through the isolation barrier. So for example, with a magnetic device, there are transformers being used, and then there's a very thin isolation barrier in between. The actual isolation barrier is only a few microns, let's say from 10 microns to 20 microns. The same is true for capacitive technology. Now, if we compare that to optical technology, the distance through isolation is much larger. The advantage there is that it is less susceptible to high voltage surges that can actually go through a device, and also to ESD occurrences happening. To sum up some of the advantages of optocouplers, the actual high voltage isolation that the device can offer is a big advantage. So working voltages for optocouplers are much higher than non-optical solutions. Also, the noise immunity inherent through the transmission via light. So the common mode rejection, which you will find in a noisy factory environment, is much higher with optical solutions. Also, if you look into electrostatic discharge, which is a big issue in many applications, optocouplers are more immune to electrostatic discharge. Optocouplers are generally used in many different application areas. Where you see a strong focus for optical technology is in industrial environments, industrial automation, motor drive systems, also in renewable energy. And the other application areas may also be transportation, right? We have train traction, power drives, automotive applications where optocouplers are being used in hybrid and electrical vehicles. So optocouplers are used in battery management systems, for example, and also in the charging of the automobile. Other future areas, depending on medical technology, there often standards are developing further for medical devices that are not necessarily found in a hospital itself, in a controlled environment, but maybe elsewhere in a doctor's office or some kind of manual medical devices where there is a risk of very high ESD discharge, and there, or surgeon transient voltages, there you need optocouplers with very high protection. So for this reason, because these markets are so important and are growing in the future, it means they're also very important markets for BROADCOM and a focus for us and also for our customers. When we speak about high voltage applications, there is a question about the lifetime of a product in the field. So if you can imagine that an optocoupler is being used in a motor drive system that is being run on a very high DC voltage. There, as this motor is being switched, turned on and turned off in a very high switching speed, there are voltage transients that are generated. These voltage transients, or high voltages, can actually break down insulation over time. right? So that's one of the concerns when you are working in a high voltage field. We can assure that our optocouplers that have been defined for a certain working voltage will actually survive over the entire lifetime of the product. One of the main components within an optocoupler is the LED that's actually transferring the electrical signal into light over the isolation barrier. And over the years, there have been many developments on the LED side. The LED technology that we use in our BROADCOM optocouplers is actually based on a history of technology that we have in-house. So we've been doing LEDs for our optocouplers for almost 50 years. And the LEDs that we are using are high reliable LEDs for our industrial and automotive optocouplers. And the developments in the past years have been to reduce the power consumption and also to have LEDs for higher temperature operation. So anyone who's had experience with LEDs will know that the lower driving current is actually a big advantage for the long life and high reliability of LED technology or products. We have a white paper available that speaks more about the actual different LED technologies being used, and I think it's a very strong message for our customers. One of the advantages that our customers have is that they can actually choose the package type of the optocoupler based on the working voltage that they need. So we offer a very large variety of packages, and if you compare, for example, some of the newer surface mount devices to the packages, the standard dip packages we had years ago, we can actually offer even higher isolation or working voltages with half of the package size. So that's one of the developments that has happened over the past years. In addition, we have newer package forms, for example, with the 15 millimeter creepage and clearance, and even devices with 1 millimeter or 2 millimeter internal clearance. Moving forward, some of the developments we're working on are more integrated packages, packages with more pins. You have more dual channels, better fault feedback loops, and different things integrated into the package. I think one of the trends that a lot of customers will see, regardless of the market segment, is that electronics always have to keep getting smaller and smaller. So board space is limited, and it's good to have isolation that is very compact. So if we look into some of the main markets that we're addressing, I mentioned before factory automation, and then a big part of factory automation are motor drive systems. And within a motor drive system, there's something that we call electrical noise. So EMI, or electrical magnetic interference, is actually part of any kind of electrical system, but this noise is more prominent within a motor drive system, for example, where you have a very high frequency and high switching speeds. So it is important that the isolation device not only be immune to the high voltages, but also be immune to this kind of noise in the system. It's something that is defined then as common mode rejection. And it's the capability of the optocoupler to reject unwanted signals that are being transferred within a system or that are there within a system. So what also needs to be taken into effect is how the device will react with electromagnetic interference or ESD incidents. Now, it's very difficult for a customer to determine what the end application will be, what environment his end product will be working in. So what happens is that customers have to go into an end equipment certification and test for ESD incidents or EMI issues. And then it's often at that stage in the design that they determine that a non-optical solution does not withstand the voltages that are in the environment. And in that case, a customer has lost a number of weeks or even months of design time if they have to go back and switch the isolation device to an optical device. When we develop a new product, you go through something called a type testing, where the device is tested at different temperatures and different vibration, shock, and also voltage levels. There you can define the actual working voltage for a device with a certain amount of certainty so that you know this device will always operate correctly and reliable for the entire lifetime. However, there is also an additional test that we can do in production to determine whether the actual insulation barrier has been manufactured correctly. That's called a partial discharge test, and that means that every single device that leaves the production line has been tested to assure that the insulation barrier will withstand a high voltage over the entire lifetime of the device. Other tests that we do are related to surge testing or, for example, even an ESD test that we do as well. So you can take the device and actually put a very high voltage surge through the optocoupler to see how it will react. And when doing these kind of tests, it's quite important to do with data communication going on at the same time. So you can see whether the signal being transferred actually gets latched or disturbed by a high voltage. So there are many tests that we can do in a lab environment, but at the end of the day, customers need to determine what kind of requirements they have in their applications. So because optocouplers are actually a safety-relevant device within an application, they are regulated by industry standards. So there's something called a components safety standard. You can actually certify an optocoupler to a international component safety standard, whether it be an IEC standard or a UL standard. And then there is also end equipment standards. So we, as a manufacturer of a semiconductor device, we will actually certify that device to a component standard. Now, a end customer who is making equipment will certify his electrical equipment, for example, to the electrical safety standard. There are certain standards for power electronics, and that will actually refer back to the component standard. So from a customer point of view, if we can offer them certified devices, they will require less time to get their end equipment certified, because it always can fall back to the component level certification. As we know that even in international standards that are not static, right? End equipment standards are also developing further. So you have the advantage with our portfolio to fulfill the standards from tomorrow, to be in line with what is coming in the future. Looking at different technologies for isolation available on the market, opto-isolation or optical technology is the strongest technology to be used in power electronics. We have done some very interesting destructive testing, for example, for IGBTs, where you have the IGBT being driven by an optocoupler. On purpose, we've done very high voltage testing to see what would happen if there is a destruction on the IGBT side, whether the optocoupler would still be able to withstand this destructive incident and still be able to protect the electronics on the other side, or in the case of a user, on the other side. The optocoupler did not work anymore. You're not able to actually transfer a signal through the optocoupler, but the isolation barrier was intact. So the user or the equipment on the other side would still be protected. So that's one of the most important arguments for safe isolation. So as power electronics further develop in motor drive systems, there is already a move or a switch from IGBTs or MOSFETs into the area of silicon carbide and GaN power electronics. And there, optocouplers offer a great advantage when it comes to the switching frequency, because there we have much higher switching frequencies and there's potential for more noise. Overall, the power electronic development will use these newer technologies to have a system that's more efficient. The size of the design will get smaller, and therefore even then the advantages of having a sound optical transmission and a safe and reliable system are even more apparent there. asked why customers should use optocouplers. And the reason is that optocouplers can offer the most safe and reliable isolation for their application. Not only do we have the higher working voltages, but also the best immunity against electromagnetic disturbances and also ESD cases. Why customers choose BROADCOM optocouplers is because we can offer very safe and reliable devices. We have a proven track record of over 50 years of manufacturing devices and devices in the field, and we make it easy for customers to have safe isolation because we fulfill all of the industry standards. This leads to short design cycles and a lot of flexibility in design for customers because they have a big choice within our portfolio. So what is so special about the working relationship between BROADCOM and EBV is that we've been working together for many years, and the long working relationship for almost 40 years together allows us to offer the customer, and EBV to offer the customer, great advantages in terms of commercial support, logistics and assurance of supply, and also technical support. So there is really design support within EBV to be able to support customers on optocouplers and other products. EBV is our sole distribution partner in Europe, and we spend a lot of time with training the field, the sales field, the field application engineers, and have a very strong working relationship when it comes to customer designs. Designers have a choice on the kind of isolation technology that they can use. But at BROADCOM, we think just enough is not good enough.